What happens when you find a fully grown monster hiding in a universe that, well, a universe that really shouldn't be old enough to have created it?
Yeah, that's exactly the contradiction we're dealing with today. It's a huge problem.
Right. And that is the exact contradiction at the heart of today's deep dive. So I want you to imagine you were scanning this sprawling, super high resolution photograph of the early cosmos. We're looking back in deep time here, examining a snapshot taken over 11 billion years ago.
Which is incredibly far back. You're looking at the infant universe.
Exactly. And amidst all these sweeping, majestic structures of early galaxies, you spot something completely, well, mundane. Just a scattering of tiny, incredibly compact red dots.
Yeah, and honestly, they look like digital artifacts at first glance. Or maybe just, distant, unassuming background noise, just these little pinpricks of dull red light scattered out there in the dark.
Right, just totally unimpressive. Which makes it all the more wild that these tiny red dots have somehow become the center of, like, one of the most intense mysteries ever uncovered by the James Webb Space Telescope.
Oh, absolutely. It's completely upended things.
So we are pulling today's insights from a really fascinating May 2026 report. This was published in the Astrophysical Journal Letters, and we accessed it via techno-science.net. And our mission for this deep dive is to decode how just one of these little red dots, when you cross-reference it with invisible X-ray data, is completely tearing up the textbook on how supermassive black holes were born.
And potentially our own Milky Way galaxy, too, right? It really highlights this beautiful reality in astrophysics where the most profound paradigm shifts, they don't always announce themselves with giant, glowing neon signs.
Yeah, it doesn't give you a giant arrow pointing at the answer.
Exactly. Sometimes they just hide in the smallest anomalies, totally buried in data sets that cross the entire spectrum of light.
I love that. So let's get into the actual physical reality of what James Webb was seeing here, because the data characterizes these red dots as incredibly compact. We're talking measuring only a few hundred light years in diameter.
Which, on a cosmic scale, is tiny. It's like a speck.
Right. And their color's super crucial here, too. The red hue isn't just, an aesthetic feature. It's actually a thermal fingerprint, indicating a relatively low temperature. It hovers somewhere between 1,700 and 3,700 degrees Celsius.
Which means the surface of these objects is significantly colder than our own sun.
Wow. Colder than the sun.
Yeah, and the contradiction there is what initially threw researchers completely off balance, because you have this object existing incredibly early in the universe's timeline. I mean, just a couple billion years after the Big Bang, and it's highly dense, it's compact, and it's cold.
So what did they think it was at first?
Well, for a while, the easiest explanation was that these were just immense, unusually cool red stars, just really big, chilly stars.
Okay, sure. But the whole cool red star theory basically falls apart the second you look at that exact same patch of sky through a totally different lens.
Right, it completely falls apart.
Because the researchers took those James Webb infrared images, and they overlaid them with the data from the Chandra Space Telescope. And Chandra, of course, operates in the X-ray spectrum, not infrared.
Exactly. It's looking for high-energy events.
Right. And Chandra had mapped this specific, highly energetic X-ray source. It's cataloged as 3D HST EGS 20A14. Catchy name, I know.
Very catchy. But the name doesn't matter as much as the location, because when you cross-reference those two catalogs, the coordinates align perfectly.
Wait, like perfectly?
Perfectly. That exact X-ray source, 3D HST EGS 20A14, sits precisely on top of one of Webb's compact red dots. So you have two massively powerful telescopes analyzing completely different wavelengths of light, and they are pointing at the exact same cosmic address.
That is wild. Which means our cold, sleepy little red dot is somehow emitting intense X-rays. And, I mean, you don't get violent X-ray radiation from a sleepy, cold red star.
No, you definitely do not.
It makes me think of an analogy. It's not even like a wolf in sheep's clothing. It's more like looking at a thermal scan of a regular hot air balloon, but then you run an acoustic sweep and realize there's a fully operational jet engine screaming inside the basket.
That is a great way to put it.
Right. Because the outside completely contradicts the internal physics.
It does. And that jet engine analogy tracks perfectly with the energy signatures we're talking about here, because the specific X-ray energy detected by Chandra is consistent with the output of quasars.
And quasars are not subtle.
Not at all. When we talk about quasars, we are talking about the most violent feeding mechanisms in the cosmos. These are supermassive black holes that are actively consuming massive amounts of surrounding matter.
Okay, so let's break down the mechanics of that X-ray emission for a second, because it really explains how this disguise actually works. The black hole itself, obviously, isn't emitting light, not even X-rays. So those X-rays have to be coming from the feeding process itself, right?
Yeah. Exactly. When immense volumes of gas are pulled toward a supermassive black hole, the material doesn't just, drop straight in like water down a drain.
It isn't.
No, it spirals around the event horizon, and it forms this massive structure called an accretion disk. And as all this material crowds together in that massive gravitational whirlpool, the sheer viscous friction between the gas particles generates catastrophic levels of heat.
Catastrophic heat. How hot are we talking?
We are talking millions of degrees.
Millions. Oh, wow. Okay, so at that point, the atoms in that gas are literally being stripped of their electrons. They're being superheated by just sheer friction. And that exact process is what blasts out those high-energy X-rays.
You got it. Which means that this dull, red, 3,700-degree object that James Webb saw, it isn't a star at all.
And what is it?
It is a massive, impossibly thick blanket of cold gas. And that gas is actively hiding a rapidly growing supermassive black hole that is just gorging itself in the dark.
That is terrifying and awesome.
Right. It's generating enough frictional heat in its accretion disk down there in the center to trigger Chandra's X-ray sensors millions of light years away.
Okay, but this forces a really major timeline issue, doesn't it? I mean, we are talking about looking at an object 11 billion years ago. The universe itself is only about, what, 13.8 billion years old?
Yeah, right around there, 13.8 billion.
So at the time this specific image was captured, the universe was less than 3 billion years old. And I was always taught that a black hole is like the endpoint of stellar evolution. A massive star lives, it burns through its nuclear fuel, it dies in a massive supernova, and then its core collapses into a stellar mass black hole.
Right, that's the standard model we all learn in school.
And then, over billions of years, those relatively small black holes merge with other black holes, they crash into stars, and they slowly accumulate enough mass to finally become supermassive.
Exactly. Astrophysicists call that the bottom-up model, or the ascendant model of formation. You start small and build up over time.
But the math on that timeline simply does not work for what Chandra and Webb are seeing here, does it?
It totally failed.
Yeah, because you can't have a massive star live its entire lifespan of millions of years, die, and then spend billions of years randomly colliding with other objects to build a supermassive black hole, all within just the first couple billion years of the universe's existence.
Right, there just wasn't enough time.
The universe literally wasn't old enough to have built something so incredibly big so slowly.
So there has to be a shortcut, right? Does the universe just, skip the star phase entirely?
That is exactly the conclusion. The evidence points entirely to that shortcut, which brings us to the second major theory in astrophysics for how these things form. The top-down or descendant model.
Okay, top-down. How does that work?
Well, in this scenario, you completely bypass stellar evolution. You don't wait for a star to ignite, live, and die. Instead, you have an immensely massive cloud of primordial gas, thousands of times more massive than our sun. And it simply collapses in on itself under the sheer, overwhelming force of its own gravity. Okay, wait, let's unpack the physics of that collapse for a second. Because if you have a gas cloud that massive, why doesn't it just ignite into a really massive star? Or, fragment into a whole cluster of smaller stars, exactly the way nebulas do in our galaxy today?
That is a great question. And it all comes down to the chemical makeup of the early universe.
The chemistry was different back then.
Completely different. See, today, gas clouds are full of heavy elements that were forged by previous generations of dead stars. And those heavy elements act almost like a coolant. They help a collapsing cloud cool down and fragment into smaller, separate pieces.
And those pieces become individual stars.
Exactly. But in the primordial universe, the gas was almost entirely pristine hydrogen and helium. There were basically no heavy elements.
Because there hadn't been enough dead stars to make them yet.
Right. So without those heavy elements to cool things down, the primordial cloud doesn't fragment easily. It stays largely intact as one giant monolithic structure.
Oh, wow. So you just have this unbroken, unimaginably massive mountain of pristine gas. And it's pulling inward with so much gravitational force that it just crushes its own core straight past the ignition threshold of a star, directly into a singularity.
Yes, a direct collapse. No star, no supernova, just a straight-to-video release of a supermassive black hole.
That is unbelievable.
And finding this hidden black hole inside Webb's little red dot, sitting right there at the 11 billion year mark, That provides the physical evidence we've been needing to validate the top-down hypothesis.
Because it proves that gas clouds can and do contract directly into black holes without ever being stars.
Exactly. It's the smoking gun.
Which totally solves the chicken or egg problem. But if I'm tracking the physics here, establishing that this is a direct collapse black hole creates an entirely new mechanical problem.
Oh, it definitely does.
Because it's about how we even know it's there in the first place.
Right. It brings us right back to the disguise.
Exactly. Because if this growing black hole is buried deep inside a primordial gas cloud that is so incredibly dense and so cold that it completely masks the black hole from James Webb's infrared sensors, how on earth are Chandra's X-rays getting through?
That is the million-dollar question.
Right. Because a gas cloud, thick enough to literally fake being a solid red star, should absorb or scatter those X-rays way before they travel 11 billion light years to reach our telescopes.
And that mechanical contradiction is exactly why 3D-HST EGS 2014 is the linchpin of this entire report. It's the whole reason this discovery is so huge, because James Webb actually found a lot of these little red dots.
Oh, it did? It wasn't just this one?
No, there are many of them. But almost all of the other red dots are completely silent in the X-ray spectrum.
Because their gas clouds are still fully intact and they're just swallowing all that X-ray radiation.
Precisely. Their internal black holes might be feeding just as aggressively, but the blanket of gas is just too thick for us to see it.
Okay, so then why can we see this one?
3D-HST EGS 20I14 is unprecedented because it is actively leaking. The astronomers concluded that we are looking at a transitional object. Basically, an object caught in the exact phase of tearing its own disguise apart.
Okay, wait. How does a black hole tear apart a gas cloud? I mean, its whole thing is pulling matter in, not pushing it out, right?
Well, gravity definitely pulls matter in, but remember that accretion disk we discussed earlier.
The one generating catastrophic heat.
Right. The sheer amount of X-ray energy and ultraviolet radiation generated by the intense friction in that disk create something called radiation pressure.
Radiation pressure, so like the light itself is pushing back.
Exactly. Light itself exerts physical force, and when the feeding process becomes violent enough, the outward pressure of all that radiation actually begins to overpower the inward pull of gravity.
Whoa. So instead of like a baby bird gently pecking its way out of an eggshell, this is a much more violent physical displacement.
Very violent.
It's kind of like, imagine turning on an incredibly powerful industrial heat lamp inside the middle of a really dense blizzard. The snow doesn't just, magically disappear. The intense heat and radiation physically melt and blast the snow outward, and it clears a tunnel, or like a window, straight through the storm.
That is a brilliant analogy. That outward blast of radiation is literally carving physical cavities into that primordial gas cloud.
So the cloud isn't gone yet?
No, the gas is still mostly there, surrounding the system, which is exactly why Webb still sees it as a cold red dot. But the radiation has punched clear lines of sight through the material.
And those clearings are the windows the report talks about.
Exactly. The feeding black hole forces these windows open, and that allows the high-energy X-rays to finally escape the cloud, travel across the entire universe, and hit Chandra's detectors.
That is so cool. And there's actually a stunning visual conceptualization to this exact process credited to NASA, CXC, SAO, and MVICE that was included with the source material.
Oh, it's a gorgeous rendering.
It really is. And it captures the mechanics perfectly.
Yeah.
You see this deep, swirling, red, cloudy structure taking up most of the frame. But right down the central axis, there is a distinct clearing. A physical tunnel carved straight through the gas.
Right in the middle.
Yeah. Through that tunnel, you can clearly see the bright, searing, white-hot accretion disk of the black hole just peering out. It perfectly visualizes the exact moment the disguise fails.
And visualizing that moment is so crucial because it really answers the so what for anyone trying to understand their place in the universe.
How so?
Because capturing a transitional object like this isn't just about logging some weird anomaly in a distant galaxy. It is about mapping the evolutionary sequence of our own cosmic neighborhood.
Oh, because almost every large galaxy we observe today, including our very own Milky Way, has a supermassive black hole anchoring its center.
Exactly. Sagittarius A is sitting right there in the middle of our own galaxy. And for decades, astrophysicists have had theories about how galaxies and their central black holes co-evolved over time. We theorize that massive black holes formed via direct collapse in the early days.
Which this proves.
Right. And we also theorize that their intense radiation eventually cleared out their surrounding gas to halt star formation, eventually revealing the bright, naked quasars we see later in the universe's timeline.
But I'm guessing theorizing the steps and actually observing the transition are two very different things.
Completely different. Before this, we had the before picture, which was just silent, hidden gas clouds, and we had the after picture, which was naked, blazing quasars.
So 3D HST AG 2014 is basically the missing frame in the middle of the film roll.
Exactly. We caught the physics in action by studying how this specific direct collapse black hole is actively punching windows through its primordial cloud. We are essentially looking at the baby pictures of galactic evolution. It totally grounds our understanding of how galaxies like the Milky Way transitioned from these dark, dense pockets of early gas into the sprawling, highly structured systems we inhabit today.
It fundamentally changes how you look at a deep field image of the night sky. So just to pull all these threads together for you, we started with what seemed like a super boring, mundane observation by the James Webb Space Telescope. Just tiny, compact, shockingly cold red dots that completely defied the timeline of the early universe.
Right, the things that look like digital noise.
But by cross-referencing that infrared data with the X-ray spectrum from Chandra, that thermal signature was exposed as a complete disguise.
Aye.
The X-rays proved that hidden deep inside those cold gas clouds were these aggressively feeding supermassive black holes.
Gorging themselves on primordial gas.
Exactly. Which provided the hard physical evidence to finally solve the ultimate chicken or egg debate. It confirmed the top-down theory, demonstrating that in the pristine, heavy element-free environment of the early cosmos, these unimaginable mountains of gas could collapse directly into massive black holes.
Completely bypassing the need for stars to live and die first.
Right. And by catching 3D HKPEJ's 2014, actively emitting X-rays through the cavities it carved in its own cloud, we gained a literal front-row seat to the transitional phase of galaxy formation.
The radiation pressure pushing back the dark, it is just a brilliant demonstration of how dynamic and deceptive the early universe actually was.
It really is. Which leaves me with a final thought to pass on to you as we wrap up this deep dive today. If this object is currently caught in transition, if its accretion disk is actively blasting radiation outward, punching windows through its primordial disguise, what happens when that process reaches its logical conclusion?
When the cloud is totally gone.
Right. Once that cloud is completely consumed or blown away, are all the blindingly bright, violently energetic quasars we see tearing through the cosmos today just the final unmasked form of these deceptive little red dots?
It makes you wonder.
And if an entire supermassive black hole can hide inside something that looks like a mundane red smudge, well, as you look up at the stars tonight, you really have to wonder, how many other types of cosmic objects out there are actively hiding their true mechanics from us, just waiting for their windows to open?